Hey there, it's Mrs. J. I'm looking at series practice number 6 from POE class. And we were just solving some random series examples. I don't have my whiteboard working properly, so I'm just going to try to talk it through so you can do this. Trying to do this in your engineering notebook. And there's 5 problems below. You should show your formulas, your work, your units. Proper engineering notation is good. Okay, so looking at number 1, it says using the circuit diagram below, solve for the missing resistance R. So this one here. You can see that we have a power source of 50 volts. And then, hey, this looks just like number 5. We have resistors 5, 3, 4, 7, and this one's missing. So we need to figure out what that is, the total resistance. So let's play with this for a minute. We know the total resistance is adding them all together, 5, 3, 4, 7, but we don't know what that is. It's omitted here, so let me see if I can type in here. What we do have is the voltage and the current. So we can use Ohm's law. And we can find, just looking at number 1 right now, we can find that the total resistance that's missing. So we go V equals I times R. Let's move it around so we know we're solving for resistance. So R would be equal to V divided by I. Right? Taking my arrow. Okay. And the reason we know that it's V divided by I, if you have multiplication here and you want the R by itself, you have to take the letter I and do the opposite. We multiplied here, so we're going to divide it. So V divided by I. And that'll give us, I'm looking at the schematic, 50 volts divided by 2 amps. So 50 divided by 2, it's going to give us 25 ohms. Make sure you're handwriting on your, it'll help you with the memory. But that's total resistance, right? Because we took the big numbers. So it's saying to find this one here. Well, we know that total resistance is equal to all of the resistors added together. So R1 plus R2 plus R3. How many do we have? 1, 2, 3, 4, 5. Plus R4 plus R5. And I'm doing, if you shift over a character, you can do Control, comma, to subscript if you're typing. You should be handwriting. It helps with your fine motor skills and your connecting and memorization. So I know that the first one was 5 ohms, second one was 3 ohms, third one was 4 ohms, fourth one was 7 ohms. And I do not know what resistor 5 was equal to. Oops, I did that wrong. So let me separate these. These are going to be equal to, can't get it, okay. So 5 plus 3 plus 4 plus 7 plus we don't know is going to be equal to 25 ohms. So I'm hoping you're able to do this math and solve this up. You can see that 5 plus 3 plus 4 plus 7 is 10, 15, 19. So you'll have 19 plus this variable is equal to 25. 25 minus 19 gives you your answer there, and you're good to go. So solve for R5. And then you can put in your answer. Number 2 says, fill in the table below. I'm just going to scooch down so I can see this. Fill in the table below the circuit diagram. Your work should be done in your engineering notebook. Upload a screenshot, show the formulas you use and the work. Remember to have a unit symbol next to any value. Okay, So total resistance is the first thing they ask for. We are in a series circuit, so total resistance is going to be equal to resistor number 1 plus resistor number 2. And if you look at that schematic that has been provided for you, it is 10 plus 20. So RT is going to be equal to 30 ohms. Make sure you write the little symbol omega, this guy, for your answer. So that's the first one. You got that. For a total, like IT. Oh, I see what it did. Okay. Control period gets me out of what I'm doing, and control comma makes it smaller. So to find the total current, you have to use Ohm's law, which we remember is V equals I times R, right? But we need to manipulate it by getting rid of that R and dividing it on the other side. So we just have to be careful we know how to do that. So I total is equal to voltage divided by resistance, and it's the total ones, right? So we're going to have, let's take a look at our schematic. It says I have 90 volts, okay, good with that. Remember, I'm dividing, and the total resistance, oh, we just got it, 10 plus 20, so it's 30 ohms. I see one up there I can steal. There you go. Okay, so 90 divided by 30 gives you total current. You put that right here. Your answer is in amps, so put an A, an uppercase A. And then for this one, I1, and this one, I2, remember that in a series circuit, the current does not change. So whatever you got, it's staying the same. So be careful you don't sit there and do some math on this. I didn't mean to do that right there, sorry. This one, control comma. So they should be equal to, Kirchhoff's law gives us this, equal to the total current, which you just got in 90 divided by 30. So it's the same answer 3 times in a current, in a series circuit. So that helps a lot. Okay, so the last thing we're going to do is V1 and V2. And I'm just going to set you up, and you should be able to do this. V1, we know that Ohm's law tells us that V1 is equal to current times resistance. So we're multiplying. I'm going to put in a multiplication symbol. That's multiplication for me. And we know we're looking at it for the first resistor, in this case. Okay, so your voltage, I'm looking at this one right here, V1. Your voltage is what we're trying to find. We're not looking for that total. We're looking for the one right at this resistor. So we're going to say that, all right, we have the current. We found it up here. We use the same one over and over and over. So whatever you got, 90 divided 30, whatever you got was in amps, that's going to be your current. Use it right here. And then the resistor is 10. So whatever you got for your current, multiply it by 10. Do the same thing one more time, if you do not mind, for the second resistor. So you're going to use the same value for the current. You have it here, here, and here. You got it from 90 divided by 30. And then you're just going to multiply it by the resistor for the second one, or 20. And then you're all done. Good to go. Okay, I'm going to look at number 3. It says, fill in the table below the circuit diagram. Your work should be done in your engineering notebook. Upload a screenshot, show the formulas you use, and the work. Remember to have a unit symbol next to any value. Okay, let's take a look. So another schematic series. We have a power source, 3 resistors, 6, 14, and 10. This means that there's a light bulb hanging out here, and there's a resistor that's protecting it from too much current. So they give us voltage, we can see total resistance, and then we don't have total current. So I'm going to walk you through this one, but we're just going to talk it through. It's the same as the one above. There's no difference. So this one, RT. The formula is RT is equal to R1 plus R2 plus R3, which is equal to 6 ohms plus 14 ohms plus 10 ohms. So you should write the formula, and then you should put in 6 ohms plus 14 ohms plus 10 ohms. And what you get as your answer is your total resistance, which looks like it is 30. 10 plus 14 plus 6. To find IT, or the total current, you're using the same one we did in the second problem. So you can go back. V equals I times R. Solve for I. So current, or I, is equal to V divided by R. So for IT, you're going to have what you got here, 30 ohms, right? And then you're going to have your 60 volts. So remember, it was I equals V divided by R. So 60 volts divided by 30 ohms. So 2 amps. For your next one, remember, it's a series circuit. So if you got 2 amps here, you're going to use the same thing. Kirchhoff's law tells us that current in a series circuit is going to run the same. Nothing is going to slow it down here. The resistors slow it down, but the current stays the same. So 2 amps, 2 amps, 2 amps. Done deal, no math, yay! And then for finding the voltage across each of these resistors, you're going to take a look at it. So V1, come up here. We know that we have 2 amps running through because we just figured that out. And we have the resistor here, which is 6 ohms. So think V is equal to I times R. So for this one, V is equal to 2 amps times 6. For this one, V is equal to 2 amps times 14. And for the last one, V is equal to 2 amps times 10. So your answer would be in volts. And you'll get 12 volts, 28 volts, 20 volts. Done deal. Make sure you're writing down your formulas. Okay, 2 more. Fill in the table below. Do your work in your notebook. Show your formulas. Remember to have a unit symbol next to any value. Okay, so series schematic. We have a power source. It doesn't say the volts. We have a resistor with 5 ohms and a resistor with 15 ohms. And they gave us the total current. So this is a nice one because it's not as straightforward as usual. It says what is voltage across the first resistor, what's the voltage across the second resistor, and what is the voltage, the total voltage. So for V1, that's the first question they ask you. We know that V is equal to I times R. Times R, which means they gave us 5 amps, and we're going to multiply it by that resistor, 5 ohms. Let me steal this guy. So you should be getting 25 volts for the first one. For the second one, it is V2 is equal to I times, keep doing that, sorry. Oh my goodness. Let me clean this up a little bit so I'm a little bit neater. And we're in a series circuit, so this needs to get out of my way. We know that we're going to use the same amps. That they gave us the current there, 5 amps, right here. I'm going to multiply it by the second resistor, which is 15 ohms. And then to get the total voltage, we want to do V equals I times R. So be careful here. This is the formula. Yeah, V equals I times R. And you just want to plug in what we have here. We have 5 amps. That's what they gave us. But for R, since we're looking for the total voltage, we want to make sure we use the total resistance. Sorry about the noise. So the total resistance would be adding these together. So 15 plus 5. So it's going to be 5 amps times 20 ohms. And your answer is in volts. Good to go. That's it for that one. Okay, so same story. Fill in the table. Show your engineering notation. I think you can do this one on your own. I'll take a quick look at it with you. Series circuit. It says find the total resistance. Your formula is RT is equal to R1 plus R2 plus R3, which is equal to 5 plus 3 plus 2. Your answer is in ohms. Just ohms. To find the total current, you need to do, let me type this in here. So the main formula is V equals I times R. Can I have caps, please? And you're going to convert that to solve for I, which means you got to take that resistor away, and it's going to be I equals V divided by R. Be careful you don't screw that up on an exam. That's a tough one. And then this guy. Okay. So they asked for total current. We're going to do V right here. It's going to be 20 volts. And then R right here is going to be whatever you got here. So 5, 6, 7, 8, 9, 10. So you have to add it together, right? Because you want the total. So 20 volts divided by 10 ohms, you should get 2 for your amps. That'll give you IT, 2 amps. Make sure you put the right notation, A. For V1, V2, and V3, it's what we did earlier up in all those other problems, and it's just V is equal to I times R. I did not mean to do that, I apologize. You have to do this 3 times. So you have V1 equals I1 times R1. You have to do V2 equals I2 times R2. And V3 equals I3 times R3. For each one, use that same total amps you got because it's series circuit, it doesn't change. So 2 amps times the resistor. 2 amps times 5, 10 volts. 2 amps times 3, 6 volts. 2 amps times 2, 4 volts. That's it. You got this. Thank you for watching.